Ever since its discovery, energy has been at the foundation of modern society because most of our technology is dependent on it. In order to satisfy our energy needs, we have found several ways to extract that energy. One of those ways is nuclear power, where we transform the heat generated by nuclear reactions into electricity. In this video, we will be analyzing what nuclear power is, how feasible it would be to implement on a large scale, and its role in our planet's future. To begin, we have to look at what an atom looks like. An atom is composed of electrons in a nucleus made of neutrons and protons. The nuclear force is what keeps the nucleus together, and it diminishes as the nucleus gets bigger. Nuclear power relies on two atomic phenomena: fission and chain reaction. Fission is the process in which neutrons are shot into a nucleus at high velocities in order to break the nuclear force, effectively splitting the nucleus and releasing energy. The broken up nuclei will then collide with the other atoms around it, which will in turn create a fission reaction and release more energy in neutrons. This process is called the chain reaction. A lot of energy is released as thermal energy, which is used to heat large amounts of water. The steam generated by this heating process is used to power a turbine, which in turn converts this mechanical energy into electrical energy. Today, about 10% of worldwide energy demand is provided by nuclear power, produced by over 400 nuclear reactors in 31 countries around the world. This makes it the fourth most used resource after coal, gas, and hydropower. The majority of these reactors are located in North America, Europe, and Asia. Nuclear power and hydropower together generate 3/4 of carbon-free energy. Nuclear alone has reduced the carbon dioxide emissions by around 60 gigatons over 50 years. The main advantages of nuclear power are the fact that it can generate electricity consistently and efficiently. Uranium contains 2 to 3 million times as much energy as the equivalent weight in coal, and sources such as solar and wind energy are dependent on the environment. In Canada, there are 6 nuclear power stations which have a combined capacity of 14,071 megawatts. In 2019, nuclear power generated 15% of Canada's electricity. Nuclear energy has by far the highest capacity factor of any other energy source producing reliable, carbon-free power. Capacity factor measures how often a plant is running at maximum power. In the United States in 2016, nuclear power plants generated almost 20% of the United States' electricity and had more than 92.3% of the capacity factor. This means they operated at full power on 336 out of 365 days per year. That's about 1.5 to 2 times more than natural gas and coal units, and 2.5 to 3.5 times more than reliable wind and solar plants. A conference organized in 2019 by the International Atomic Energy Agency had speakers who reported that nuclear power can contribute to meeting the goals of the Paris Agreement on climate change and the UN Sustainable Development Goals. More specifically, it can help attain SDG 7, affordable and clean energy, and SDG 13, climate action through minimal emission processes of generating energy. With increasing energy demands, choosing sources that are sustainable is necessary to mitigate climate change and work towards goals 7 and 13. Nuclear power releases almost no emissions or air pollutants during operation and is the second lowest emitting energy source of electricity following hydropower. However, a major concern of nuclear energy is the creation of radioactive waste that can remain radioactive and dangerous to human health and wildlife for thousands of years. Although nuclear power does not release direct carbon dioxide emissions or air pollution, disposal of the waste is expensive and must be done carefully. Accidents can cause the release of radioactive materials into the environment, and the effects are extremely harmful to humans and wildlife. Furthermore, the process of mining and refining uranium ore and making fuel is energy intensive, and any emissions from the construction of the nuclear plant or mining can be associated with pollution from nuclear power. Worldwide demand for electricity, especially clean, is only going up as population and urbanization increase. The U.S. Energy Information Administration projects that world energy consumption will grow by nearly 50% between 2018 and 2050. Nuclear power is potentially a strong solution for the rising demand for clean energy going forward as we shift away from fossil fuels. To follow SDG guidelines for sustainable energy, we need to generate solutions to the problem of nuclear waste. One possible option is a long-term geologic repository which still stores nuclear waste deeply underground indefinitely. If we are to expand nuclear energy use, there is a clear need for innovation in dealing with the waste produced. In conclusion, nuclear energy has the potential to meet the clean energy demands of our developing world. The technology is there and we can make very efficient use of it. As we explored in the video, we see that nuclear energy has advantages over other sources of energy such as efficiency in generating electricity and no emissions or air pollutants during production. These factors make it a very strong renewable energy source that can provide vast amounts of clean energy to us. Although it cannot provide alone, nuclear energy stands beside renewable energy sources such as solar, wind, hydro, and geothermal as the world shifts towards a sustainable future.